Another type of conic section is what we call an ellipse. It's sort of a circle flattened out in one direction or another. So an ellipse could be horizontal, a circle squeezed on the top and the bottom, or it could be vertical. All right, and in either case, an ellipse has a center point. Okay, so there's the center of this ellipse, and here of course is the center of this ellipse. Alright, something else is they each have a big axis and a small axis. So what I mean by that is a horizontal ellipse has a big horizontal axis, and a vertical ellipse has a big vertical axis. And that axis, the length of that, or that axis is called the major axis. So the major axis. And it has a length, of course. And then each of these ellipses also has a a short axis. In this case it's vertical, in this case it's horizontal, and I bet you can guess the name of that short axis. It is in fact the minor axis. And it also has a length. Notice that each of these axes passes through the center of the ellipse. Okay, so those are some basic parts. Let's get the other parts of an ellipse down. Okay, I've got my ellipses here with their centers drawn. There are 4 critical points on an ellipse. The 2 points on the ends of the major axis are very critical. Those points are called, each of them is a vertex. If you recall, a parabola has a single vertex. An ellipse has 2 of them. So plural for vertex is vertices. So I'm writing this in blue down here rather than crowd up the picture at the top. So the 2 points on the end of the major axis are called vertices. The other 2 critical points for graphing an ellipse are the 2 points at the end of the minor axis. They're not technically called vertices, so we might give them a different name, maybe call them the minor vertices. Minor vertices. As a matter of fact, I think some books call them vertices. You know, some books say that an ellipse has 4 vertices. So, I mean, it's not that big of a deal. Okay, finally, if you recall, also a parabola had a focus. Ellipses have 2 of them. So, plural for focus is foci, F-O-C-I. And they are located on the major axis within the ellipse. So these are the foci. The ellipse wraps around the foci just like a parabola wraps around its focus. Over here, they're on the major axis as well, and 2 foci once again. Okay, so what's the relationship between a focus, a vertex, and a minor vertex? Well, let's see if we can understand this. Let's measure some distances here. Let's say the distance from the center to a focus, let's call that F for obvious reasons. And then let's say the distance from the center to the vertex is capital V. And finally, let's measure the distance from the center to the minor vertex, and let's call that lowercase v. Let's do the same thing over here. I'm just going to label them the exact same way. What I want you to notice is capital V is the largest of these 3 numbers. Okay, it has to be. Capital V is definitely bigger than little v. It's the major axis. It's also bigger than F because it's further away from the center. So the relationship between these 3 values is much like the Pythagorean theorem. Take the sum of the squares of the smaller 2, f squared plus little v squared, and you get capital V squared. So the big one is like the hypotenuse of some right triangle. And that's the relationship.